Yeah, these multi-things components, they each define their requirements using OCL, so that we can set, for example, a requirement to say that on a technical level, a component requires a camera with at least 4 megapixels or something like that. And on the other hand, we have those IoT devices, and they specify their capabilities using an object diagram. So the object diagram is an instance of this class diagram that represents our hardware ontology. And since the OCL requirement refers to the class diagram that specifies the hardware ontology, and the object diagram too is written against this class diagram, we can then later on match the OCL requirement against the object diagrams from the IoT devices to find out which devices are capable of running which pieces of software. Yeah, at runtime, we also have the device owner that can configure the app, as I just said. We also have the end user that can interact with the devices, and we have a couple of cloud services, for example, to establish communication, digital twins, and things like that. So this leaves us basically with this pipeline that we see here. So we have the IoT app store operator that has to specify which hardware is to be expected. And he does that using a class diagram, saying, for example, that there are cameras, that there are temperature sensors, or something like that. We have the device developer who specifies the capabilities of each device that he develops, so which concrete specific sensors are present on the devices and which capabilities they have. So, for example, an accuracy level or something like that, a field of view for a camera. So the specific properties of the hardware. We have the application developer, and those write, on the one hand, the behavior of the application using those multi-things models, those architectures. He also can define some high-level features, for example, that there's a certain security component and a certain light control component, and these can then be used to later on give the device owner a more abstract view of the application, so that he doesn't need to look into the actual application code, but just can select the features that he wants instead of specific pieces of software. And he also defines the application requirements using OCL statements, so the technical requirements of each component. And then there's device owner. The device owner specifies the rules for the individual instantiation of the application. So as I said, for example, a fire extinguisher in each room. Most of these now get transformed to Prolog code. So we have a rule engine, and basically there we define the facts about our system, so that there are devices present and that devices have certain capabilities, and that there are certain requirements within our system. And we also have then rules that request certain properties from the system. And then Prolog can either find a solution to that problem, saying which device needs to run which software, or we can make a proposal for some changes. So, for example, to buy a new device and place it into your bathroom or something like that. And in the end, then we can tell each device which software to download and execute. As I said, we have the possibility to use feature diagrams, and those then tag the different components that they need. So, for example, we can have, so that in the end we can have more abstract features to present to the user, and not need to present the user the internal structures of our application, just to make it easier for them to understand. And we can also then, using this feature diagram and the information that we have about the system, for example, propose useful configurations to the user. For example, give me the feature configuration, the maximum feature configuration that's possible with the hardware I already own, instead of leaving them with the blank feature diagram and then letting them choose what they want. And yeah, in the end, as a specific example, this then looks like this. So we have, on the one hand, the object diagram that specifies a concrete device. So, for example, we specify here that we have a certain distance sensor, and then we can specify the properties of the sensor. So, for example, what's the range of the sensor, the accuracy of the sensor, and things like that. And this is basically an instantiation of the ontology that we see on the right side. So this is provided by the App Store, and the left side is provided by the device developer, or on the bottom from the application developer. And using the OCL statement on the bottom, the developer can then define what they actually need. So for example, that they need a distance sensor to cover a certain range to be useful, and thereby we prevent having a sensor that's the right type of sensor. So for example, it's a temperature sensor, but it's not capable to measure the actual properties that we would need to run the application. So for example, if we have a temperature sensor that can measure only between 0 and 10 degrees Celsius, but we want to measure something like minus 10 degrees up to 30 degrees, we need a different kind of sensor, and then we can match which devices actually fulfill our requirements. And then in the end, we all, you don't need to understand this, but just to see that there's some Prolog code in the background that's then generated from all these models. So we have, on the one hand, some facts that specify which devices there exist. And then we also, in the end, produce some rules that can be used to find out which devices are capable of running which software. As I said, the hardware is matched against the software shortly before actually executing it, and therefore we have this access manager that then basically connects these black parts from our components to the actual handwritten code from the device developer. And this code does not have to be in C++, but it can also be in Python or whatever fits your sensor driver best. So in most cases, the vendor of the actual hardware component provides you some driver library, and then we made the experience that is in most cases the easiest to just use the library that's provided by the hardware vendor instead of writing a totally new application. And just to finish it, we did a small case study. This is basically what you've already seen. So our smart home application here. And for that, we then defined a feature diagram with some more high-level features, so that there's, for example, a door lock or light control. And we defined which components belong to which features. And in the end, the user can then basically select which features he wants, or we can calculate for the user what's possible with the hardware that he already owns. So to give one short example, we could, for example, here have a camera and then require that a certain component requires a camera with at least 4 megapixels. And on the other hand, there are components, so hardware components that, like this Raspberry Pi camera, actually have those 4 megapixel cameras and then provide it to the system. Yeah. Thank you for your attention. And now it's time for questions.
Thank you. Thank you. Well, thank you. Any questions? No? Oh, yes, please. That's for microphone. I think it's on.
I have a question related to the OCL in Prolog. So you're using it to identify whether a solution is working or not. And if it's not working, do you have some features to explain why it is not working to the...
Right. So basically what we generate there is a long rule, and for each case where it doesn't work, we also generate alternative solutions. And then we can basically provide an explanation to the user and say, for example, that you requested a smoke detector in each room, and let's propose there is no smoke detector in your bathroom because you think that's unnecessary, but your rule requires it. Then our explanation would be that there's a mismatch between the rule and the actual hardware that you own, and that you could resolve that, for example, by buying a new smoke detector and placing it in the bathroom. And let's suppose you don't want to do that because you still think it's unnecessary. Then you can just say to the system that you want a different proposal from us. And then we will calculate a different proposal, for example, like to adapt your rule to require only a fire detector in each room without the bathroom. And then you either get at some point in some equilibrium between the user and the system that you can say that the user is now happy with the adapted rules or has bought the necessary hardware and the system can now fulfill all rules, or you have to just start over again because there's no solution that makes both the user happy and the system happy.
Okay. I think basically your system, you're addressing sort of the standardization issue. So I'm wondering what kind of software platform has to be provided by the hardware, because you talked about the Docker container stuff. So I think you assume that Linux is running on every device. I'm wondering, which kind of a specification requirement you suppose.
That's correct. We basically use the same model that's used by Azure, AWS, and all those. So they have a differentiation between more capable devices, the edge devices, and those are the ones that we can use here. And they also have some very low power devices like an ESP32 or some microsensor. And those cannot be used to deploy new software from the cloud onto the microcontroller. So we can also use them in our system, but in this case, we cannot deploy new software onto it because in the background, technically, we're basically using either one of those cloud services or Docker or Kubernetes or a research project called Genesis from the EU. And then we try to use either of their deployment mechanisms in the background to actually download the software. But we can only integrate those very low power devices without Linux if we don't deploy new software onto it.
So it's basically you're interested in a little bit higher level of the system, and you want to apply the product line architecture to that layer.
Right. So our goal is to find out which device can actually execute which software and then deploy it to those. But it has to be a certain level of capable to do that.
I see.
So if it can't download software, then we can do nothing about it.
Okay. Thank you. So if there is no any other questions, we will. Yep. Quickly.
Hi. A lot of those properties are these days illustrated in an asset administration shell.
I'm sorry, can you speak up a little?
Yeah. The asset administration shell is administrating a lot of those properties of different devices. Are you using that as an input, or is you have to reprogram? Do you know about that one?
I've never heard about it, but we, if I have to assume what it is, I hope we would be able to integrate that because we already have, as I said, 4 different vendors in our system, and basically you just need a way to tell us which devices have which capabilities, and we don't enforce a specific kind of mechanism to tell us this. So we can use either Azure with their tags on devices, or we can use Kubernetes, which has also a mechanism to tag certain properties, but we can also just use raw JSON files which are sent to us. But in the end, we just need a way to access the information, but we don't enforce a specific type of technique there.
Okay, thank you very much. Let's thank the speaker again.